Hello, welcome to Math 1960, Section 301, Calculus 2. This is UNO Summer Session number 3. So today we will be discussing summary of tests, choosing the appropriate test to determine whether the series diverges or converges. So first thing is we check to see if the series is a geometric series or a p-series. If yes, then we use the conclusion given for this series in table number 6. So we find the limit of a sub n of the series. If limit of a sub n not equal to 0, then we know that the series diverges. If the series a sub k has only positive terms and meet the condition of the integral test, then we use the integral test. If the series a sub k has only positive terms and nth term is quotient of the sum of difference of powers of n, the limit comparison test can be used. If the series a sub k has only positive terms and the preceding attempts fail, then we try the comparison test for conversion or the comparison test for divergence. Series with some negative terms. For an alternating series, we use alternating series test. It is sometimes better to use the absolute convergence test first. For other series containing negative terms, always use the absolute convergence test. If the series a sub k has non-zero terms and involve product, factorial powers, the ratio test would be the good choice. If the series a sub k has non-zero terms and the n terms involve an nth power, try the root test. So as you know from here that there is no one way of getting these testing done. So you use your judgment, you use your experience to come up with the right test in the right time. So test for divergence, this is similar to what we just discussed, but right now is tabulated. So for this is a divergent test. This is number 1 divergent test. So in divergent test, if a sub k diverges, then limit a sub n not equal to 0. No information given when a sub n is equal to 0. So for integral test, a series with positive terms. So the first thing, it has to be positive terms, it has to be continuous, and it has to be non-increasing. So then we use the integral test. But also, as you know, when we are using integral test, the integration must be easy. So comparison test for convergence for series. For series, we come up with the comparison series that is greater than or equal to that series at all the time, and then we come up with the conclusion from that series, and that conclusion also apply to the other series that we are trying to determine its divergence or conversion. Okay, also the limit comparison test. In limit comparison test, we will have a series of positive terms. If a sub k converges or diverges, that means b sub k also will converge or diverge. So the limit comparison test is, we divide a sub n always by b sub n. Okay, alternating series. In alternating series, we use the limit to actually find whether the series goes to 0 or not. If the series goes to 0, then we know that the series converges. There is the so-called the absolute conversion test. If the absolute value of the terms of the alternating series converges, that means the series also converges. And the root test and the ratio test. So these are the well-known terms. Geometric series is well known, and then the harmonic series. and then the P series and the K to K series. These are the well-known series. Okay, that so which one of them converges? Every one of them converges except the harmonic series don't converge. Okay, so just every time look out and try to know whether the series converges or not.